Welcome to Math TV with Professor V. In this video, we're going to learn about arithmetic sequences. So an arithmetic sequence is basically a sequence in where you have a common difference, which is just basically some number that you keep adding to get from one term to the next. So let's look at the formal definition. The sequence A1, A2, A3, all the way up to AN, and it could be an infinite sequence, is called an arithmetic sequence or an arithmetic progression if there is a number D such that each term in the sequence, except the first, is obtained from the preceding term by adding D to it. And that number D is called the common difference of the arithmetic sequence. If you're trying to figure out what D is, you basically take one term, some arbitrary term, doesn't matter which one in the sequence, we'll call it A sub n plus 1, and then you subtract the term that came before it, which would be A sub n. So let's just take a look. And for the first example, we're going to determine whether each sequence is arithmetic. So just say yes or no. And then for those who are arithmetic, find the first term and the common difference. All right, so this is going to be the first term. Now look at the second term. If I take 4 and subtract 2, that would give me potentially what the common difference is if this is arithmetic. So let's see. 4 minus 2 is 2. So basically we added 2 to get from the first term to the second. And then just repeat and see if this is consistent. So from 4 to 8, or 8 minus 4, we added 4. Already you can just stop, because in an arithmetic sequence, you should be adding the same number every time. It should still be a 2. And then things just get even worse. Look at this. Now we're adding 8 and then 16. This is actually a geometric sequence, which we're going to study later. So nope, this one is not arithmetic. So we don't do anything else. Okay. If it was, and it started off 2, 4 with us adding 2, then we would have to keep adding 2 every single time, like that. Then it would be arithmetic. All right, let's look at another example. Example B, we have 2.3 as the first term, and then 2.7 is the second term. So let's see, 2.7 minus 2.3, we added 0.4. And then from 2.7 to 3.1, yep, same thing. Same thing. 3.5 to 3.9, same common difference. You have to check for every term that they list. All right, if one doesn't match up, if you're adding something different, then that means it's not arithmetic. One can ruin it for everybody. And you just check for every single term that's listed. The ... just means assume they're keeping up the pattern that they showed you. So yes, this is arithmetic. Woohoo! And then what else did they ask us to do? Find the first term. So the first term is A1. The first term is 2.3. That's pretty clear. And then the common difference is D. That's whatever we were adding to get from one term to the next. So that's 0.4. All right, easy enough. Do you guys have a good feel now for what an arithmetic sequence looks like? Okay, now we're going to move on to finding a formula for the general term of an arithmetic sequence. So here's our definition. If the sequence A1, A2, A3, up to AN, etc., is an arithmetic sequence, then its nth term, or the general term, A sub n, is given by the following formula. So this for sure you need to memorize. AN is equal to A1, where A1 is the first term, plus n minus 1 times D. So A1 is the first term, like we talked about, and D is that common difference. Memorize this. Okay, good. So let's practice using that definition as we work through the next examples. Example 2. Find the nth term of the arithmetic sequence whose initial term A and common difference D are given. What is the 51st term? All right, lovely. So let's see here. They told me for example A1 or A sub 1 is equal to -2 and D is equal to 4. So we're going to use definition for general term of arithmetic sequence. AN is equal to A1 plus n minus 1 times D. So they've told me already, all right, A1 is equal to -2, and then I have plus n minus 1 times D, which is 4. Don't leave your answer like this. You want to distribute, clean up. So I'm going to distribute the 4 now, and I have AN equals -2 plus 4n minus 4. And then if I combine like terms, -2, -4, that's going to be -6. So I'll put AN is equal to 4n minus 6. All right. So I took care of the first part of the problem, the part that asked me find the nth term of the arithmetic sequence. And then now there's the second part, we have to find the 51st term. So for the 51st term, in that case, we're just going to substitute in 51 for n, since n indicates which term of the sequence we are working with. So A sub 51, and then now we're going to use the formula that we just found for the nth term is equal to 4 times 51 minus 6. So 4 times 51, that's 204. Minus 6, this is 198. So that's what a 51 is. All right, good. Not too bad, right? Let's try another one. Here we have A1, the first term is 1, and D, the common difference is -1/3. All right, why don't you guys pause the video, give this one a try on your own, and then check back and see how you did, okay? All right, good. I'm going to rewrite the formula. I recommend you do that every single time because it'll help you memorize it faster, okay? So AN is equal to A1, which is 1, plus n minus 1 times D, which is -1/3. And then again, let's distribute. So AN is equal to 1 minus 1/3 n plus 1/3. And then we can combine like terms, 1 and 1/3, that's 4/3. So we can write AN equals 4/3. Whoop. 4/3 minus 1/3 n. So there's our formula for the nth or general term. All right, and then part 2 asks for the 51st term. So now I'm going to substitute in 51 for n. So we have 4/3 minus 1/3 times 51. And we already have a common denominator, don't we? So we have 4 minus 51 over 3, which would be -47 over 3. So that's what a 51 is. All right, not too bad. How'd you guys do? Did you get it right? Okay, I hope so. Let's move on. Look at some more applications here. Example 3, find the indicated term in the indicated sequence. All right, so they want the 80th term. 80th term means n is 80, right? Of the following sequence, -1, 1, 3, etc. So I don't have the formula to get the nth term just yet, but we'll find it, don't you worry. So we're going to use A1 plus n minus 1 times D. Can you guys tell me what A1 is? Yes, it's not a steak sauce. A1 is -1 here. Okay. And then what is D? What's the common difference? Can you tell how much we're adding every single time? 2. Correct. So D is 2. So now we have our formula for the general term. An is -1 plus n minus 1 times D, which is 2. All right, now it's up to you. You can distribute and clean it up. I didn't this time because it just asked for the 80th term, so I knew I was just going to be plugging in 80 for n right here, so I just jumped straight to that. Okay, so a sub 80 is going to be -1 plus 80 minus 1 times 2. And this is going to give us -1 plus 79 times 2. So 79 times 2, that's 158. We have -1 plus 158. So that means the 80th term is 157. All right. Good. I hope you didn't think we were going to sit there and just keep adding 2 until we hit the 80th term. That would be wild. All right, good. So I hope you can all appreciate that it really all stems from remembering the definition for getting the general term of an arithmetic sequence. You have to memorize this. Very nice. Okay, got an example for you that's a little spicier. Are you ready? I hope so. So find the common difference. So that means find D and the nth term. So a sub n, the definition of the arithmetic sequence with the specific terms. So here they're telling us the 5th term is 12 and the 18th term is -1. All right, let's rewrite that using our notation for sequences. The 5th term is 12. That means a sub 5 is equal to 12. And then they also told me the 18th term is -1. So that means a sub 18 is -1. Now we know a sub n equals a1 plus n minus 1 times d. So I have, for example, if the 5th term is 12, that means n is 5. So a sub 5 is equal to a1, I don't know a1, plus n minus 1, so 5 minus 1. Do I have d? No, I don't, times d. All right, this might look scary, but it's not so bad. They told me a sub 5 is 12, so that equals a1 plus 4 times d. Good? Now just put this on the back burner for now. There's 2 unknowns, right? A1 and D. And I only have one equation at the moment. So that's why we're going to work with the other piece of info that they gave us, and then we'll be able to solve for our 2 missing variables here. Okay, so let's repeat the process now with the fact that the 18th term is -1. So that means a sub 18 is equal to a sub 1 plus n minus 1, in this case n is 18, minus 1 times d, right? N is 18, look at the subscript, that's n. That's n, that's n. All right, and what did they tell me the 18th term was? They told me it was -1. So -1 equals a1 plus 17d. Now look at what we have right here. I have a linear equation with 2 unknowns, a1 and d, and then I have the exact same thing, linear equation, 2 unknowns, a1 and d. This is just a system of equations with 2 variables. We've solved this already. You can use elimination or substitution. I'm going to use elimination. So I'm going to rewrite these equations up here. Let's just leave 12 equals a1 plus 4d alone as is. And then this one I'm going to multiply by -1 so that a1 will cancel out. So now I have 1 equals -a1 minus 17d. Do you see what I'm doing? It's nothing new. You did elimination plenty of times. It's just usually with x's and y's. So don't get scared because the variables have switched up on you, or maybe you weren't expecting to do it, right? You're like, oh no, I'm doing sequences. What is this? You have to remember all your math. Okay, 12 plus 1, 13. Love it. A1 cancels now. Look at that. And then this is equal to negative 13d. Divide both sides by negative 13 and we get d is equal to negative 1. Okay, good. So now I know d is equal to negative 1, but remember I'm still missing a1. So go back to either of the yellow equations that I've circled so we can find a1. Let me just go with the first one here. So we know that 12 is equal to a1 plus 4 times, now I know d is negative 1. If I add 4 to both sides, then I get that a1 is 16. All right, so now we're ready to put everything together. So now we have an equals a1, which is 16, plus n minus 1 times d, which is negative 1. Distribute. An is 16 minus n plus 1. So final answer, all cleaned up, an equals 17 minus n. All right, and did we answer everything? They wanted the common difference. Well, we already got that. D is negative 1 and the nth term right here. All right. Hopefully that wasn't too over your head, but this is a more involved example for sure. So I have another one for us to practice. Go ahead, pause the video again, give this one a try on your own, and then check back in. Let's see how you did. Just mirror the steps that I set up for you in example A. Example B has no sneaky tricks, okay? I promise. All right, how did you do? Did you get some fractions in there? Did they make you nervous? I hope not. Okay, let's separate things a wee bit. Here we go. So they told us that the 11th term is negative 1. Okay, so that means A11 is negative 1. So that means A11, which is A1 plus n minus 1 times d, this is equal to negative 1. So one of your equations should be negative 1 equals a1 plus 10d. And then the 31st term is 5. So a sub 31 is 5. That means a sub 31 is a1 plus 31 minus 1 times d, which would mean 5 equals a1 plus 30d. So these are our two equations. I will box them in yellow again. Two equations with the same two unknowns. So you can solve the system however you like. I'm going to go ahead, multiply this first one by negative 1, and then I'm just going to rewrite it underneath here. So now we have positive 1 equals negative a1 minus 10d. Adding these two equations, we have 6 equals a1 cancels out, 20d. Now don't get nervous. Yes, this is a fraction. D is equal to 6 over 20, which is 3 over 10. All right, that's our common difference. Very good. Now we have to get a1. Go to your favorite place. I'm just going to use this equation right here. Okay, so negative 1 is equal to a1 plus 10 times d. D is 3 over 10. Oh, and that works out because these 10s are going to cancel. So negative 1 equals a1 plus 3. Subtract 3, so a1 is negative 4. All right, now we can put everything together. So our formula or rule for an is going to be as follows. So an is equal to a1 plus n minus 1 times d. d is 3 over 10. Go ahead, let's distribute 3 over 10. So then we have an equals -4 plus 3 over 10 times n minus 3 over 10. Good. If I get a common denominator, -4 is going to become -40 over 10. -40 over 10 and -3 over 10, that's -43 over 10. But I'm going to put the 3/10 n first because it's positive, and then minus 43 over 10. And now we are done. Okay, how did you do? Did the fractions cause you to have a meltdown, or were you able to power through? Don't let them frighten you, okay? Just because there's fractions doesn't mean that the problem or the rules or the formulas or math changes, all right? Very nice. Last idea has to do with summing up or adding the terms of an arithmetic sequence, okay? So let A1, A2, A3, up to AN, etc. be the first n terms of an arithmetic sequence with common difference d. The sum, Sn, of these n terms is given by the following. Sn equals n divided by 2 times A1 plus AN. And this you should memorize as well, but I have a little story for you to help you remember it, okay? So the story has to do, or it's like a little legend about Gauss. You can look it up. So little Gauss, famous mathematician, when he was in school, it seems like all the children were being very naughty for the day and the teacher had had enough of everybody. And just so that they would be quiet and leave the teacher alone in class, he said, everyone sit down, add up all the numbers from 1 to 100. And the teacher thought, oh, this will take them forever. They'll be out of my hair and I can, not deal with these punks for a while. And then little Gauss was done within, lickety split. I don't even know how long. And the teacher was amazed. And this is what smart little Gaussie did. So the task was to add up all the numbers from 1 to 100, right? So let's see. Gaussie did not just sit there and add them all up in order. No. This is what he did. He said, okay, 1 plus 100, that's 101. And then 2 plus 99, that's also 101. 3 plus 98, how much is that? Again, 101. And so on and so forth. How many 101s do you have? Well, you're adding up all the numbers from 1 to 100, so you can make half that many pairs, right? So you would take this, 101, you have this 50 times. So you would do 101 times 50, and that gives you the sum of all of the numbers from 1 to 100. And that's where this rule comes from. So look, the sum, say, of the first 100 numbers, right? This is an arithmetic sequence because you're just adding 1 every single time. So it's the most basic arithmetic sequence. Is n divided by 2, well, that's the 50 pairs. However many terms you have, cut it in half. That's why we had 50. And then A1 plus AN, that means the first term. That means the last term. That was the 101 that we had. And just remembering that story helps me make sense of the formula for summing up the terms of an arithmetic sequence. And hopefully it'll help you too. So that's why I told it to you. Okay, and you might hear different variations when you Google it, but something along those lines. Okay, let's make some space here since we have work to do. Cut. Okay. So find the sum of each arithmetic sequence. What we need is n, A1, and AN. Okay. A1 I can see clear as day, it is 1/3. That's the first term. AN, the last term, is 7. But I don't know what n is. How many terms am I adding up here, right? There's that ... in the middle. They're not telling me. Is 7 the 100th term? Is it the 23rd term? I don't know, so I got to figure it out, all right? I need to know and use my old formula, what is n that yields 7, okay? So can you guys tell me what the common difference is? How do you get from one term to the next? How much are you adding? So we have 1/3, then 1, then 5/3. You can just subtract the term that precedes, right? Any term to figure out the common difference. So 1 minus 1/3, that's 2/3. So here our rule for the nth term, an, would be a1, which is 1/3, plus n minus 1 times d, which is 2/3. All right? Good. Now let's clean up here. So an equals 1/3 plus, distribute here, 2/3 n minus 2/3. So that leaves us with an equals 2/3 n minus 1/3. Okay, that's the rule for the general term, And I know the last term here is 7. So let's figure out what term that is. So I'm going to replace an here with 7. So 7 is equal to 2/3 times n minus 1/3. I'm going to add 1/3 to both sides. Okay, if I get a common denominator, 7 is 21/3. So if I add another 1/3, that's going to be 22/3 equals 2/3 times n. And then I'll multiply both sides by 3/2. So I can cancel out the coefficients. And then 22 divided by 2, that's going to give me 11. So what does that mean? That means this is the 11th term. This is actually a 11, which is equal to 7. Woohoo! So n is 11. Now we're ready to roll. Let me write out the formula for summing up the terms of an arithmetic sequence. Sn equals n divided by 2 times a1 plus an. So now I know n is 11. So S sub 11 equals 11/2 times a1. A1 is the first term, 1/3, plus an, which is 7. Okay, now we did some of this fraction work already. Remember, this is 21/3, plus 1/3 is 22/3. So we have 11/2 times 22/3. 2 cancels. 11 times 11 is 121. So S sub 11 is 121/3. And leave it like that, okay? Did the problem have decimals to start with? No, it did not. So don't start busting out decimals if they didn't tell you to, or they didn't set the tone with them, okay? That's the general rule of thumb. If they're using fractions in a problem, then you better stick with that. Look at the next one. My goodness, I see decimals. So that's my cue. It's okay to use decimals in my answer. Okay, here we go. Find the sum of the first 100 terms. Okay, so that means n is going to be 100. Of the arithmetic sequence 3.5, 3.7, 3.9, blah, blah, blah. So I need the first term. That's 3.5. And then let's remind ourselves, what's the formula? So Sn is n divided by 2 times a1 plus an. Let's see what we have. I actually know n is 100 this time, right? Ooh, different than last time. So that equals 100 divided by 2 times a1, which is 3.5, plus a sub 100. Ooh, that I don't have. okay. So we got to figure out what is the 100th term. We got two options. You can sit there and keep adding the common difference till you get to the 100th term. You want to do that? I don't. I would rather use the rule for figuring out the nth term. Remember, an is a1 plus n minus 1 times d. So if I want the 100th term, I know a1 is 3.5 already, plus 100 minus 1 times d, the common difference. Can you tell what the common difference is? Hopefully, we're just adding 0.2, right? Every single time. So d is 0.2. All right, good. So let's see, this is going to be 3.5 plus 99 times 0.2. 99 times 0.2, that's 19.8. So we have 3.5 plus 19.8. So this is 23.3. Okay. What does that mean? That means the 100th term is 23.3. So now I can substitute that in here and figure out the sum that they asked me for. All right. So now we have S100 is equal to, instead of 100 divided by 2, I'm going to put 50, okay? Good. 50 times 3.5 plus 23.3. And then this is going to give us 1,340. All right, so that concludes the lesson. Hope you enjoyed it. And like I said, coming up next is geometric sequences. This one doesn't want to get boxed. Okay, there we go. So we'll look at another kind of sequence. And then we're pretty much done with the unit on sequences and series. And then when it's time for you to take calculus, you'll see them again. How exciting.